finishing up chapter 10, we're going to look at some applications of Taylor series. And I've mentioned in the last couple sections that there are certain functions that might be difficult to integrate or find limits for, just hard to work with in general. And that is where the Taylor series and the Taylor polynomials come in. They can help simplify the process. So we're going to focus here on a binomial series. And this is going to come from a Taylor series, and let me turn my pen on here. The binomial series here is going to come from the Taylor series generated by the function f of x equals 1 plus x to the m power, where m is a constant. And we get this binomial series where it can be defined as such. We've got 1 plus the sum from k equals 1 to infinity of this m over k, and I'll define that a little bit more in just a moment, times x to the k power. So the way this is going to be defined is you're going to take whatever your m is, whatever that starting value of that constant m is. So m over 1 here is just going to be m. For the second one, it'll be m times m minus 1 over 2 factorial. If you had m here over 3, it would be m times m minus 1 times m minus 2 over 3 factorial. And so on. That's how that is going to work. And that's going to give us the binomial series. So what we're going to do is we're going to do a few examples here, writing out some binomial series. For the first 2 examples, we're just going to look at the first 4 terms. So I'm not given 1 plus x just raised to a power here. I've actually got 1 minus x to the negative 3rd power. So I can think of this, as 1 plus negative x. And let me turn these into brackets here. Raised to the negative 3rd power. So instead of an x, we're going to use a negative x. And our m value here is going to be negative 3. So the first term is just a 1. That part's easy. And then we're going to go into this here. So first thing we're going to have is m over 1. So it's just going to be our m value, which is negative 3. And since this is the first term of the series, it's going to be x to the 1st power. But in our case, we've got negative x to the 1st power. Now, moving on. So we're in the 3rd term of the binomial series, but the 2nd term using this here. So it's going to be negative 3, and then we're going to subtract 1, so times negative 4 over 2 factorial. And then normally it would be x to the 2nd, but again, in our case, it's negative x to the 2nd. And then one more term. So the 3rd term again here, so it's going to be negative 3 times negative 4 times negative 5. We're just subtracting 1 each time over 3 factorial. And here it's going to be negative x to the 3rd power. So cleaning this up, we have 1. Then negative 3 times negative x will be plus 3x. Here, negative 3 times negative 4 is positive 12. 2 factorial is just 2. 12 over 2 is going to give us a 6. And negative x squared is just x squared, so we have plus 6x squared. And then here, we have negative 3 times negative 4 times negative 5. When you multiply negative 3 times negative 4 times negative 5, you're going to get negative 60. 3 factorial, 3 times 2 times 1 is just 6. So you have negative 60 over 6, so that would be a negative 10. However, negative x to the third is going to be negative x to the third. So negative 10 times that negative gives us a positive 10x to the third power. So there are the first four terms of the binomial series for that function. So we're going to do it again. Here we've got 1 plus 1 over x to the 1/2 power. So this time our m value is 1/2, and instead of just having an x here, we've got 1 over x that we'll have to deal with. So we've got 1, then plus 1/2 times 1 over x to the first power. Then my next term is going to be 1/2, and then it's 1/2 minus 1, so times negative 1/2 over 2 factorial. And then we'll have 1 over x squared. And then for the last term, it's going to be 1/2, then negative 1/2, and then subtracting 1 again, negative 3/2 over 3 factorial, and then 1 over x cubed. So we have 1 plus 1 over 2x. Here, 1/2 times negative 1/2 is a negative 1/4 in the denominator, or sorry, in the numerator. So we have negative 1/4 divided by 2, that's going to be negative 1/8. And then we're going to also have an x squared in the denominator, so it'll be minus 1 over 8x squared. Then here we have 3/8 in the numerator. Negative and negative make a positive. So we have 3/8 divided by 6. So that's 3/8 times 1/6. 3 cancels into the 6, so that gives us a 16th in the denominator. And then 1 over x cubed is going to give us an x cubed in the denominator. So here we have plus 1 over 16x cubed. Now with these first two examples, we could just keep repeating this. You could add as many terms as you like to these series. Depending on the m value though, sometimes your binomial series will have a definite end to it. And let me show you what I mean by that. Here it says find the binomial series for the function, excuse me, 1 minus 2x to the third power. So that is the same thing as 1 plus negative 2x, and then the whole thing to the third power. So here our m value is 3. So writing this out, we're going to have 1 plus 3 times negative 2x to the first power plus 3 times 2, because you're subtracting 1, over 2 factorial times negative 2x squared plus 3 times 2 times 1. Again, you just keep subtracting 1 over 3 factorial. That's times negative 2x cubed. And if you try to go again, you're going to have, excuse me, 3 times 2 times 1 times 0. So it's going to zero out the term. And for every term after, you're going to have that 0. So everything beyond this point is just going to zero out. So this is all you have here. So let me clean this up a little bit. We're going to have 1 minus 6x. Since 2 factorial is just 2, these 2's are going to cancel. Negative 2 squared is 4, so you have 3 times 4, or 12x squared. And here, the last term, 3 times 2 times 1 is just 3 factorial. So this whole fraction cancels out. Negative 2 to the third power is going to be a negative 8. And then x to the third power is just that. So here is the binomial series for this function, which you could find by just multiplying out this function.